anyone can watch them. But usually what I'll do is I'll start off our classes with a spiritual thought, and then I'll kind of dive right into our course content. We weren't able to meet last week. Our week was cut short, but we'll meet every Monday from here on out. And weeks 1 and 2 are pretty light anyways. So I'll go ahead and cover that content today, answer any questions if you guys have any questions. And then we'll go through all of our week 2 stuff. So let me go ahead and start off with our spiritual thought. After this, Brady, would you be up for saying our prayer for us?
Yeah, I could for sure do that.
Thanks, I appreciate it. Okay, so I had an interesting conversation with my daughter this morning. I have a 6-year-old who started kindergarten this year, and the last couple of weeks, she hasn't been super excited to go to school. Some of the days she is, but other days she's not. And she's like, Daddy, can I not go to school today? And she'll like keep on asking me if she can like stay home from school. And I'll be like, no. And then this morning she asked me a funny question. She's like, Daddy, am I going to have to go to school for the rest of my life? I'm like, kinda. I don't know, I'm just kidding. But I felt kind of bad with the answer that I gave her. I'm like, well, think about how long you've been alive. Now double that, and that's how long you'll be in until you graduate in high school. And then you'll probably have college, and then depending on what you do, more college, and then depending more college still. And she seemed a little put out by my response. But I was thinking about it, and she asked me why she has to go to school, and we got into a good conversation about life and the importance of learning and what that does for us. And it made me think of a scripture in Mosiah 24. At this point, Alma and his people are in bondage. And so horrible was this bondage that they couldn't even pray. If they were caught praying, they'd be put to death, which is pretty extreme. But anyways, in verse 10, it says, and it came to pass that so great were their afflictions that they began to cry mightily to God. Verse 12, and Ammon and his people did not raise their voices to the Lord their God, but did pour out their hearts to him. And he did know the thoughts of their hearts. And it came to pass that the voice of the Lord came to them in their afflictions, saying, lift up your heads and be of good comfort, for I know of the covenant which ye have made unto me, and I will covenant with my people and deliver them out of bondage. You know, it's interesting. He didn't just tell them this as soon as they started having these afflictions. He didn't just come out and be like, hey guys, I know you're struggling, but I'll remember the covenant that you made and it'll be okay. But no, it was after they started crying unto him and poured out their hearts to him that he said that. And it made me think of the Lord and how loving he is and how much he wants to help us. You know, and so often in my life, like, I know he's there. We talk about it every Sunday in church. We talk about it every time we have family night. I know that he's there. I know that he loves me. And yet so often in my day-to-day life, I don't seek out his help. And so I don't get it, you know, and in our lives, if we can just come to him, then he will bless us more than we could ever imagine. But he does wait for us to come to him in most cases because he needs us to exercise our faith. He knows that that is a huge part of our learning process, and our growth is being able to exercise that faith and to come unto him. But every time we do that, he is so anxious to bless us. And so I would encourage you, as you think about school, if it seems daunting like it does for my daughter, like it'll never end, like it's hard, maybe pointless, just remember that the Lord is there for you. And if you rely on him and if you put him first in your day-to-day life, you will feel him bless you in ways that will feel miraculous in your life. And that's my thought for today. Brady, go ahead with the prayer.
Thank you for that thought, by the way. That was awesome.
Yeah, you're welcome.
Our dear Heavenly Father, thank you so much for this day and for the opportunity that we have to be in class and learn and grow to become more like thee. Heavenly Father, this time as we learn in class, we ask that we can have the Holy Ghost with us to prompt us and help us learn as we should, that we can retain the knowledge and that it can come easily as we devote time to it. Please help us that we can have a great day today and always remember thee in our hearts and minds continually and rely on thee. We're so grateful for the opportunity I have to be here in school. And again, please help us as we work hard. And we say these things in the name of Jesus Christ. Amen.
Amen. Thank you. All right. Well, before I dive in, talking about the class, setup of the class, and chapters 1 and 2 in the book, does anyone have any questions for me? Sweet. I will take a silence as a lack of questions. So let me go ahead and share my screen. All right. I know that I'm welcoming you to cit160 a little bit late, but we did start 5 days ago. I know that you guys have had a week's worth of work due since then. But like I said, thankfully week one's pretty slow. But as we go into 160, I have a couple of tips for you guys. So always review assignment feedback. This assignment feedback, I have a TA, Nicholas Cable, who will be grading your programming assignments. I have requested of him that he grade these within 2 days of when they're due. So they're due Saturday night, and I've asked him to complete them by Monday night so that you guys can get feedback on your assignments early. This will help you if you guys struggled with anything or you missed points on something. Look at that feedback, see where you missed out, see what you were lacking, see what else there was to learn so that when you go ahead and start working on your next assignment, you're ready to rock. Review the spreadsheet for recordings and videos each week. So our video spreadsheet is in the syllabus. So if I look at the syllabus, and the link for this document is in iLearn in the syllabus section. If I look in here and I go down, there's a section called Where to Get Help. Where do I get help? Okay. There's a help document that has a bunch of stuff in it. We'll look at that in a second. One of which is the video spreadsheet. So I'm going to go ahead and open this. I'll also open up the help document as well. But here's what the video spreadsheet looks like. Okay. Now where this came from it was just a lot of questions from students, a lot of similar questions. And I'm like, you know what, I'm going to make a video for this. And then it turned into this whole spreadsheet. Okay. And so anytime you're working on a proof assignment, I've made an introductory video for you to say, hey, here's what the assignment's asking. And sometimes I write a little bit of code. Sometimes I'll write some comments in the code to kind of give you a direction, kind of walk you through my thought process with that. And then after it's due, a walkthrough video becomes available. Now, yes, these walkthrough videos are like the answer. Okay, there's a lot of different ways to write code, but this is a solution to all of the proof assignments. Now, this is made available to you after it's due. And in our grade book, I don't really accept late work. All right. Well, I do to an extent. Every day that an assignment is late, it is docked 20% all the way down to 0. So if you wanted to watch one of these videos the day after something is due and then finish it, I'd be fine with you getting any help that you need from my videos. But when you submit, you'll be docked 20% per day that it's late. But these are here to help you. I hope that you're able to complete your programs without these videos. You guys will have lots of discussions with classmates and with me participating in those discussion boards on Slack. And so really you should be able to get these assignments completed. But these walkthrough videos can still be helpful to you to look back and be like, okay, I wonder if there was another way to do this, or I did it, but I feel like it took me a really long time and I feel like there could be a better way to do it. Or even just to see how somebody else could have done it. These videos can help you there. Recorded lectures from week 2 all the way through week 13. I will do this with you guys. Okay, we'll just have a recorded lecture and I'll post the link here and anyone can go back and watch them. Completed programming exercises. These are not locked. These are from your book. And so if I looked in chapter 3, I did the first exercise from the end of chapter 3. Or in chapter 6, I did the first exercise here. These are not the same as your assignments, but at the end of every chapter, all of the programming exercises that they have are really similar to each other. And so watching these can be helpful too. And then over here on the side, I've kind of set up things by chapter. And so if there's something in iLearn you don't understand, or how to set up VS Code and how to use VS Code and different things, these videos might be helpful for you installing and using Slack in the course. Let me just pull up Slack real quick. Most of you guys are on here. I've been reading through your introductions and I've been enjoying them thoroughly. But this is what Slack looks like. We have a few channels over here. Announcements are where I will post things for you guys. We have a class help channel. So if there are just random questions about the class, like, hey, where's the Zoom link today? Or when is this due? Random things. We are all on this. And so anyone can answer questions on here. An extra credit channel. If you get a lot of help from someone and you feel like someone deserves extra credit, you can nominate them for extra credit here and they'll get extra credit. A random channel, sometimes people put programming jokes on here or announcements that they got engaged, just random stuff that you can put on here and share with the class. And then all of these are our discussion boards. Okay, so week 1, pretty much everyone posted on this introductions channel, just introductions, and it was awesome reading through them. And then starting in week 2, we'll have our peer review discussion boards where everyone will actually post their code, and you'll be required to post and respond to peers on here, and everyone can get help. You know, if you can't figure something out or you got close, you know, you'll do your best, you'll post here, get help, and then your final code submission will be on Friday of that week, or Saturday of that week, excuse me, Saturday. Okay. Okay, any questions about Slack? Okay, I'm gonna request that all course communication happen here. I love these messaging things down here. Anytime you wanna send me a message, just hit this plus button. Type in Nathan or Brother Birch, I'll come up and you can send me a message. It's really nice because then if I ever send you a link to a help document or something else to help you out, it'll never get deleted like emails do. It'll just be there. You can go back and look. Or if you ask me questions about something, I won't forget, because next time I talk with you, I can see what we've previously talked about. And despite my terrible memory, I'll be in the right spot to help you guys out. So please only message me in Slack, not in iLearn and not over Outlook or via email. All right, the help document. So this I made for you guys to kind of basically help you be autonomous. Okay, online classes can be tough because you don't have someone sitting right next to you a couple times a week to help you out. You know, if you have a question, you can't be like, hey, come look at my computer. Can you help me out with this? You know, so online classes can be tough. And so this is a list of places that you can go to get help. The iLearn course content, the chapters are great. A lot of them have like interactive exercises that you can do to get practice with stuff. The video spreadsheet we already talked about. Google, most of you have heard about that. Here are some tips on how to get programming help using Google. The help channel in Slack. This is huge. Anytime a student sends me a programming question, 99% of the time, I'll be like, this is a great question. Can you post it on Slack on the help channel? And I'll answer it there. Because usually if you have a question about something, you know, there are 30 or 60 other students looking at the same thing, and you're not the only one with that question. And so I'll have you post on the help channel, and then we can all get help there. The tutoring center, there are tutors for this class provided by the university at no cost to you. Okay, so you can go to this link and get tutors for this class or any other class. Our class TAs, we have Nicholas Cable this semester, and he is awesome. Well, one of his primary functions is to grade all of your stuff, but also if you need additional help, sometimes he's available to help. Set up a meeting with me. Okay, this link, if you go here, there'll be a list of times that I'm available to meet, and you can just click on one, set up an appointment, and it'll get added directly to my calendar with the Zoom link, and we just both go there at the same time, and you can set up appointments with me anytime you need. And then for more general support, there's the Online Support Center and IT Help Desk for more like computer or iLearn related issues. Okay. Questions about where to get help in this course? Okay, sweet. Well then, let's keep going. Do extra credit, okay? There are a couple of forms of extra credit in this class. One of which I will always post a spiritual discussion in the announcements on iLearn every week, every Monday morning when it'll get posted. And on there, if you respond to the spiritual thought, that is some extra credit. And then if you respond to at least one peer, that is more extra credit. That's as much as you can get. You could respond to 20 peers if you wanted, but you'll only get credit for responding to one. But that's extra credit you can do the entire semester long. All right, between that and helping people out on the help channel to get extra credit there are ample opportunities to get extra credit throughout this semester that could actually make up several assignments worth and really help you out. You know, if you don't do as well on an exam as you wanted to, or you miss an assignment, or you were late on an assignment, I would encourage you to do the extra credit from the get-go so that you can benefit from it fully. Understand the late work policy. We already talked about it, 20% per day that something's late. Week 1 deliverables, we're going to skip that because we already talked about, well, we already passed week 1. Computer hardware, I'm going to kind of fly through this because it's mostly in the past. And I say mostly because it will be on your exams. But when exams come around, you'll know that you just have to look back at chapter 1. I'll give you guys study guides. But basically, we'll just look at some of the parts of a computer today, and then we'll move on to lesson 2. So semiconductors, microscopic parts of a computer that partially conduct or sometimes conduct electricity. 5 main types. We have a capacitor, diode, LED, resistor, and transistor. Integrated circuit, generally composed of billions of semiconductors etched on a small piece of silicone. That kind of blows my mind, by the way. Generally called a computer chip. Parts of a computer, most of us should be pretty familiar with these. The bus might not be super familiar. The bus is basically just electrical circuits that allow data and electricity to be transferred to different parts of a computer. The BIOS is the first piece of software that runs when a computer powers on. Okay, so if I was going to turn on my computer, the first program that runs is in my BIOS, and that tells it what operating system to boot up and how to boot it up and when to do it and all sorts of things. Main memory, that is just, there's a type of main memory out there that has kind of taken over the world. It's called random access memory, or RAM. So generally we just call main memory RAM. And it's just a temporary memory on your computer. We have a hard drive, which is a non-volatile type of memory, which just means if your computer powers off, whatever's on the hard drive doesn't get lost. Wherein whatever's in main memory, if the computer powers off, is gone. The CD or DVD drive, jump, thumb, or flash drive, these are all extensions to the computer. Okay, if I plug a mouse into my computer, or if I plug in a thumb drive into my computer, these all extend the functionality of my computer, and all eventually direct or connect directly to my motherboard to connect it to the rest of the parts of the computer. The CPU is the central processing unit where logic takes place in a computer, and where computations and commands are given. And then the cache, another type of main memory generally used to help in running programs on your computer. Data sizes, we have a bit, byte, kilobyte, megabyte, gigabyte, terabyte, petabyte, and exabyte. All get bigger. A nibble is never really used, even though it does exist. It's kind of a computer slang term for half of a byte, which is just 4 bits instead of 8 bits. A binary number. So my wife, she was asking me a bunch of questions about this the other day. She's like, what's a bit? What's a byte? What's the difference? And basically, I could think of like my light switch as a bit, a binary number, okay? If it's a 1, then my light switch is flipped on. If it's a 0, then my light switch is flipped off. A binary number is 0 or 1. That's all it is. It's just a bit, or that's a binary digit, excuse me. But our binary number can be many, many digits. Okay, so a nibble would be 4 digits. It might be 0011 or 1010, or just 4 digits, all ones and zeros. And then a byte is 8, a kilobyte is 1024, and so on as we get bigger and bigger. Clock speeds. A clock within a CPU is a small electrical circuit that repeatedly produces an electric signal that pulses. A single core in a CPU is designed to complete one instruction at the end of each pulse. So hopefully you guys read through this last week, but the way that I like to think of clock speeds in a CPU is like this. So if I was helping somebody move, we have the U-Haul parked in the driveway and they have a living room full of stuff, okay? They have like a massive lamp that I have to be really careful with. They have a small box of glasses from the kitchen. They have a massive couch, all right, that it's going to take 2 people to carry. Now, clock speeds does not represent how much I can carry. Clock speeds represent how many trips I can take, okay? And so, if I can make 2 trips every minute, then that would be my clock speed, regardless of I have a fragile lamp that I'm holding or a couch that I'm carrying with another guy. Okay, clock speed simply represents how many trips I can take. Now, when we start getting into processing power and RAM and different things like that, that is when that load changes. Okay, so for each trip, I could carry 50 pounds or 60 pounds or 20 pounds, depending on some of those other attributes. Common classes of computer. We have micro or personal computer designed to be used by only one person at a time, such as a smartphone, tablet, laptop, or desktop. A workstation, a powerful computer designed to be used, again, only by one person at a time. Many of you will end up having what is classified as a workstation. Okay, it's just a computer with a really powerful processor, 32 to 64 gigs of RAM generally. They're just fast, powerful computers that can handle really heavy programs. And mainframe, a very powerful computer designed to be used by many people at the same time. Okay, there are many computers that you can connect to remotely from any location. You have your own keyboard, you're working with it like it's your own computer, but it's such a big computer that lots of people are using it at the same time. Software, computer hardware won't do anything without some instruction. Okay, so all those parts of a computer that we talked about, that you read about, they're all great, but they won't do anything by themselves. That's where software comes in. We have two main types of software. We have an operating system, which after the BIOS runs, the operating system is what you use to interact with, your computer and the hardware. But the operating system is kind of the bridge between you and the hardware. And then we have applications, which are computer software that someone uses to accomplish a specific task. So right now on my computer, I have Google Chrome open, Slack, Outlook, my File Explorer, probably some other things. But all of these are pieces of software that would not run without an operating system. I need an operating system to run them because those pieces of software don't know anything about the hardware of a computer. The operating system, though, knows everything about the hardware of a computer. And so those who write operating systems have to learn how to interface with hardware, and those who write applications have to learn how to interface with operating systems. Character data, everything in a computer's memory is stored as a number or set of numbers. We kind of already talked about this with bits, the binary digits. At the baseline, that's how everything's stored. Computers aren't very smart. When we talk about billions of semiconductors etched onto a piece of silicone, those are all bits. Semiconductors are either on or off, true or false, a binary digit, 0 or 1. And so every piece of data that's stored, it uses a bunch of bits, okay, so to be able to store that data. So if I look at my name, Birch, right here, every character has its own number. Okay, you notice the capital B is different than a lowercase b. But then I could also convert these numbers into binary. So if I just said, let's say decimal to binary, anytime I have a number like 98, we call those decimal numbers. And so if I had 98 and I wanted to convert it to binary, there's the binary number for that. Okay. And so I could look at my whole name. I don't remember what the other characters were, but let's say those are the next 3 characters. Oh, no one wants to do one at a time. But basically everything at the baseline is stored in binary, and operating systems will not break it down quite that much. The computer will do that. But ASCII is a very common code base. Unicode is also a very common code base that has all characters that you've ever seen. Chinese characters, Hebrew characters, Spanish and Portuguese characters, everything. Execution example. So this is just kind of to depict at a rudimentary level, what happens when you're using your computer. So if a user clicks on a Microsoft Word document, say like on the desktop, the operating system commands the hard drive to copy Word into main memory. So once the application is in main memory, then the computer can actually use the application. After Microsoft Word is in main memory, the operating system executes Word and sends a command to Word telling it to open the document that the user double-clicked. Microsoft Word requests the operating system to read the document from the hard drive and to place it in main memory. The OS commands the hard drive to copy the document file into main memory. The hard drive copies the document file over a bus, and then for each character that's in the document, Word reads the character's Unicode number from main memory and requests the operating system to draw that character in a window. The operating system finds the Unicode number and its corresponding symbol in a table and draws it. Okay, so pretty intense. So when you hear like numbers like billion, and that our CPU can process that much stuff, that number starts to seem really small when it's like, oh, for every single character, it's going to take several commands to actually show it on the screen, and so, but this is an example of how our computers actually work. Okay. Questions on last week's content? I know I just zoomed right through that, but it's because it's already passed and you're not gonna have to worry about it until week 5. Okay. So let's dive into week 2. All right. Week 2 deliverables. Chapter 2 review questions are always due on Tuesdays. Robbie the robot. So you will post a rough draft on the peer review discussion board in Slack by Wednesday night at midnight. Then you'll do your peer review. You have to comment on people's code by the end of Thursday. And then you'll submit your final code Friday. And the peer review journal and self-assessment survey are due Saturday night. Now, I get confused with dates, and so don't take my word for anything. Just look in the calendar. One thing also that I like to do a lot of the time when I'm a student in a class, do I not have iLearn open? Oh, I do have iLearn open. Okay, give me one sec. Oh, sorry about that. You guys are seeing other people's grades. Okay, so I'm going to go into our course. So a couple of ways that I can navigate this. I can go into modules and I can see when everything's due. I can click on the calendar and see when everything's due. And then kind of as a last check, I always go into the syllabus. And then I look here, like, okay, what day is it today? Today's the 11th. So tomorrow we have the chapter 2 quiz, coding assignment instructions. Then the 14th, we have this one. And then the 16th, we have these ones. Okay. And so I use the syllabus kind of as like a last check just to make sure that I have everything. But usually I'll just like go through the modules, but that's just me personally. So, all right. So pay attention to the course and the course calendar. All right. Algorithms and computer programs. Okay. One does not simply write an algorithm. An algorithm is a list of steps to perform a task. We use defining tables, okay? So when I think about a task that has to take place, very frequently it looks like an elephant. And we have to think about, okay, if I was gonna eat an elephant, how would I do it one bite at a time? I don't know if you guys have heard that before. But a defining table helps us do that. It helps us to conceptualize the input, output, and processing that will be required in a program. So let's assume you work for a large construction company. Your boss has asked you to write a computer program that will read a list of window openings for a building and compute and output the total cost of all the windows. The window openings are entered in inches with the width first and the height second. The cost of a window is computed by multiplying the area of the window in square feet by 35. So thinking about this, what would the input be for this program? Think.
It should be the inches.
Yeah, for sure. So if I'm going to compute the cost of all the windows, I'm going to need the dimensions of each window and then each window, right? Oh, whoops. Okay, what is the output going to be?
Well, I think we also have that amount of times the inches that we are inputting.
Yeah, so that's the processing, okay? So the processing is all the math that I have to get from point A to point B. Point A is my input, what we have to input. Our output is just the cost, okay? And then the processing would be, okay, I have to think about each window, get the area for each window, and then multiply that area by 35, and then I'll add all the windows together, right? And that'll get me my output. So a finished defining table might look like this. Okay, the input, list of window openings, width and height for each. Then for each one, we compute the square feet, multiply by 35, add to the total cost of all the windows, and then we output our total cost. Okay, so the defining table really helps us to kind of break down that process. And if I look at the prompt here, I can see a couple of things. So right here, a program that will read. Seeing that read, I know that I'm gonna have an input here. So read a list of window openings for a building. and then compute and output. Here's our output, total cost of all the windows. So I could put that here in the output right here. Okay, that's what I have to output to the user. And then right here, we see some details on the processing. The window openings are entered in inches with the width first and the height second. Okay, that was input. And then processing the cost of a window is computed by multiplying the area of the window in square feet by 35. Okay. Let's look at another one. You've been asked to write a program that will read from the keyboard the radius of a circle. Okay, so there's our input, and we'll output to the monitor the diameter, circumference, and area of the circle. Okay, so here's what we get. We have the input, which is the radius, output, diameter, circumference, and area, and then the processing. So for this, for each one, I said, okay, for the diameter, it's just 2 times r. Circumference, 2 times pi times r. And then area, pi r squared. Okay. All right, so algorithms. If it is a list of steps to perform a task, okay, we could think of that as anything. Okay, we could think of it in programming. We could also think of it as a recipe. We could think of it as tasks on a to-do list or sentences in a paragraph. Okay, but algorithms will always have steps to perform a specific task. For this one, with baking cookies, you can see here all of the instructions to do it. All right, so let's look at this one. Go ahead and take a look at this for a sec and tell me what's missing in my algorithm.
Well, I would say first to close the fridge door.
Ooh, okay, we never closed the fridge. That's not good. My kids would dive right in there and start pulling everything out. Okay, what else? What else do we miss?
You left, so the pantry, the cupboard's open. All those doors are open still.
Okay, great. What else?
Maybe I would specify the type of cereal. Maybe there's 2 or 3 types of cereal, so just to specify that.
Awesome, great.
You're also missing a spoon.
We're missing a
and
spoon.
so it's kind of hard to eat without a spoon.
Yeah, might look more like this, except with milk. Okay, anything else that you guys see? Okay, well, great, you guys. Computer programs are simply composed of data and instructions. Data is stored temporarily in computer's main memory and more permanently on the hard drive. Instructions are called statements and are similar to steps in an algorithm or sentences in a paragraph. These statements or lines of code tell the computer what to do with the data. Computer operations. So like I said earlier, computers actually aren't very smart. They're only capable of performing a few basic operations. They can receive data, which we call input. They can write data to the computer or output. They can assign a value to a variable or memory location. So if I wanted to like save my name, I could save that in a variable and then access that variable later. Perform arithmetic. Okay, so here we have a few operators. We have negation. We have multiplication, division, modulus, addition, and subtraction. And if you're like looking at this and you're like, wow, this is tough. We are not going to go into that for a couple of weeks. Okay. Compare two values, relational operators, lesser than, greater than, etc. Again, these, I don't think we cover these until like week 7 or 6 or 8 or something. Repeat a group of actions. That's like week 8 or 9. Call a function and return from that function. That's like 10 or 11. Okay. So we are going to learn how to do everything on here. Okay. In this class. All high-level tasks that a computer can do, such as edit photographs, play music, play games, search data, are simply combinations of these basic operations. At the very core, this is all a computer is capable of doing. But when you like pile them all together with code and use them all like thousands of times in different ways, then you can like play Netflix, okay, or edit photographs or or anything. Control structures and the flow of execution. So a control structure basically says what order your code will execute. All right, so default is top to bottom. Easy to remember, it's like reading a book, okay? If I have 10 lines of code, I'll just run from line 1 down to line 10, one after the other. But there are things that can kind of throw off that default. Okay, we have selection. We generally think of this as if-else logic. It is what makes our computers appear to be able to make decisions. Okay, so let's say I have a website that I go to log in on. I type in my email and password, and if the password is correct, it'll log me in. If the password is incorrect, it'll pop up incorrect password or something along those lines. But that is this type of logic that we're talking about. Repetition, repeat a group of statements, which is while logic. So if I want to do something, I can say, okay, well, while the user inputs an incorrect password, we're going to keep on allowing them to enter a new one until they get it right. Function call and return, execute statements in a function and then returns it. And then try, catch, throw. We're not going to look at that too much in this class, but it is another thing that changes that default control structure of top to bottom where code gets executed. All right. And that was chapter 2, you guys. So any questions on anything that we just covered with chapter 2? Okay, sweet. Well, like I said, weeks 1 and 2 are pretty slow. Don't grow complacent because of that in this course. It really picks up in like week 5. Okay, so our plan for this course, week 3, you'll learn HTML, which I'll look at a little bit here with you in a sec. And then week 4, you'll learn JavaScript, and the rest of the semester, you're doing JavaScript stuff. So HTML and JavaScript, they are 2 different languages. We will simply use HTML to house our JavaScript and watch it run. But then JavaScript is what we're actually going to be programming in. So let me show you guys something real quick. I'm just going to open up my text editor. I'm going to close that. You all should have Visual Studio Code downloaded on your computer or another text editor. If you guys chose to do another text editor, that's just fine. I'll be using Visual Studio Code. And what I like to do, and every text editor I've seen can do this, is I like to open up a folder right here so that I can look at my files and I can kind of just go through them, and it's really easy to see all my files. One nice thing too is I can like right click on a folder, and if there was something that I did at some point, I was like, oh, I know that I used, you know, like an if statement at some point. Well, I can search in that folder and find everywhere that I used an if statement in that whole folder, which is really slick. Okay, now to open up a folder here, all I have to do is hit File and Open Folder. Okay, another thing that I can do, I'm going to open up a new window here so you guys can see this from scratch. So let's say I have a folder on my computer called cit160, which I do, and which you should too, okay? But maybe this folder above it is called like school or something, and then you have a folder called cit160 or 160 programs or something. I can just click on this folder and drag it over into VS Code, and it'll do the same thing as if I clicked on Open Folder, okay? And then it'll be open here with all my programs, okay? So it's really nice having your folder open because it makes it really easy to navigate your code. Now, what I'm going to do, I'm just going to make a new file in here. So I'm going to right click here and hit New File. If you're already in your folder, you can just click on this and that'll make a new file too. But I have a number of different classes open right here. So I'm just going to open one inside of cit160. I'll say New File, and I'll say temp.html. Now, I'll say week 1 temp.html. Notice that I said .html. Now, if I was working with a Word document, it'd probably be like English paper .doc or .docx or something. But that file extension on there would be different for an English paper or for a picture or a movie than it would be for an HTML file. HTML, anytime I want to write HTML code, I'll just say a file name, which can be anything I want, and then .html. If I don't put that .html there, my computer won't recognize it and won't run any code. But now that that's here, I can start writing HTML code. All right. Now, quick little tip for you guys. In VS Code, if you type in an exclamation mark and hit tab, it'll kind of give you a little HTML template. Now, I love doing that because I don't like having to type this over and over again. But I also have another template right here that I actually use anytime I want to like do an assignment for this class or something, which I encourage you guys to make in week 4. But if you want to see mine in our cit160 videos, I'm pretty sure it's this one right here, the chapter 4, exercise 3, is when I made my template file that I use the rest of the semester to just like copy and paste anytime I wanted to make a new file. But for right now, let's go ahead. I'm going to save this. And if I want to run this file, I just right click on it and I hit copy path. Now this is basically saying, you know, wherever this folder is on my computer, I'm going to copy that location. Okay, so I'm going to copy it and watch. If I paste it right here, here's what the path looks like. My C drive on my Windows computer, folder called Git, cit160, and the file name. It's just the location on my computer. But if I put this into Google Chrome and paste it, web browsers are really good at rendering HTML. Okay, so I know this doesn't look like much because we haven't really done anything yet, but this one thing right here tells me that we ran this file successfully. It says document, and if I look back here, my title for the HTML file says document. Now if I say document testing and hit save, come back over to Chrome and hit F5, you can see it updated to document testing. Okay, so it's running my HTML file, even though I don't have anything here in the body of the HTML. Now I come back over here, and let's say I wanted to do a header, okay, or like a headline or something. If I type in H, VS Code will automatically show me every HTML element that starts with H, which is pretty slick. So I'm going to click on H1, and I'll say this is a big heading, and I'll hit save. The hotkey for that is Control S. And then I'm going to go over to my browser and hit F5. And you can see now it has that heading in HTML, which is pretty slick. Okay. But basically, anytime I want something to display on the page in HTML, I will put it in the body. So if I wanted to do a paragraph, I could say this is a paragraph. I could save it, come back over here, hit F5 to refresh, and you can see it rendered that as well. Okay. But we still have the rest of our document. Okay, we have the head right here, which basically is like the settings for our document. Okay, we say what character set we want it to use. We have our meta name, which helps anytime we want to like Google anything, and then also with how it's going to look on the page. We have the title, which shows what text we're going to have in the tab. If we wanted like a little image, like you see with these other tabs that I have open, that would be right here as well inside of the head. And lots of things would go in here, but basically the head is for like the settings of the document. If I wanted to write JavaScript, which we're going to do for the rest of this semester, if I typed in script and hit tab, in here, I can write JavaScript code, which is a different language, and it will run even though this is an HTML file. But then inside the body, this is stuff that will actually appear on the page. So here's a cool little thing. Let's say I wanted to show a picture on the page. All right. I'm just going to Google, let's see, sunset. And I'm going to click on images, find one that I like. That one's pretty. And so I'm going to click on it, and I can just right click on this and say copy link address. Now I can test this. If I just hit paste over here, it should just open up that image. Oh, but it didn't. Okay, it went to an address. I want to copy the image address right here. Okay, so now let's test this again. Hit paste, and there's our image. Okay, so that'll work. I'm going to come back over here, and then in the body, because I actually want this to show on the page, I'm going to type in image and tab, which will open it up. And VS Code is really nice because it just typed out all that for me. The way I did that is I just, once one of these was selected, I just hit tab or enter, and it filled in the rest of that for me. And then for the source, I will just put that link, and I can hit save and go back to my document testing and hit F5. And look, there's our image right here in our HTML. That's pretty sweet. Okay, well, it's pretty massive. I kind of want it to be smaller. So now we start getting into like styling. All right, and so in here, I can add what's called a style attribute and say width is 300 pixels or something. Come back over here, hit F5, and you can see since I didn't specify a height, it just kept the same ratio, but my width is now 300 pixels. Okay, and so I know that looking at this, it's a lot. It's like, holy cow, I don't understand all that code. I don't understand why there's all these quotation marks and lesser than and greater than signs and backslashes and forward slashes and all this stuff. Okay, I know that it looks like a lot. The reason why I show you guys this right now is to give you an idea of where we're going. Okay, so week 3, you'll be able to do all of this within like 10 days. I know it seems daunting now because you haven't learned it yet, but seriously, in 10 days, you'll be able to do all this. And yeah, you might have to Google stuff. Yeah, you might have to look back at the book. Yeah, you might have to come back to this class or next class and be like, okay, how did he do that image again? Or how did he do that header? How did he make VS Code type in all that image stuff? Oh, he hit tab. But you guys will learn this. In week 4, we'll start diving into how to use this script section and how to use JavaScript. Now, if I was going to talk about HTML and JavaScript and what the difference is, HTML basically just shows stuff onto the page. Okay, it's very straightforward. It's basically just like reading a document. You know, in Microsoft Word, when you open up a document, it just shows it. It's there. If you think about JavaScript, JavaScript would be more like Excel and being able to like do math and perform functions and show you what day it is. You can do all of that with Excel, and you can do all of that with any programming language. And so right here, if I wanted to do something, I could say like alert is a function in JavaScript. And I could say this is JavaScript and hit save. Now, when I run this, notice this isn't in the body. Okay. So this isn't going to display on the page, but instead it's going to tell JavaScript to do something. So I'm going to come over here and hit F5 and look what it did. My page says it's still loading. And here's a little pop-up that says this is JavaScript, or more accurately, an alert that says this is JavaScript. All right. And so JavaScript will help me do all sorts of things with my program that I can't do with just HTML. Okay. JavaScript will make it so that these HTML files, these web pages, will actually be stuff that can do things, which is really cool. And then once you hit OK, it'll go ahead and load up the rest of the page. So, and that's pretty much where we're going. And the rest of the semester, like I said earlier, you know, we'll learn about how to do math. We'll learn about how to do if statements. We'll learn how to do loops and write functions and all sorts of stuff. So that's a bit of where we're going. Any questions on anything you guys just saw? Okay. Well, that is all I had for you today. So I think I'm going to let you all go. I will post this recording once it's available, and I hope you guys have a great week this week.
Thanks.
Thank you so much.
Nothing.
Okay. Thank you guys. I'll talk to y'all soon.
Thank you.
Yep.
Bye, guys.